Matter is all around us, shaping everything we see, touch, and feel. But what exactly is it, and how does it behave? In this episode, we'll break it down in a simple and engaging way to help you understand the different states of matter and their importance in everyday life. Have you ever wondered why ice melts, why steam rises, or how we smell food from a distance? Understanding this topic will help us make informed decisions about our surroundings and how we interact with nature and technology. Matter is anything that occupies space and has weight. That includes the air we breathe, the water we drink, and even the ground we walk on. But what is matter made of? Matter consists of tiny particles called atoms, which combine to form molecules. These particles are always in motion, which explains many properties of matter and natural phenomena. The particle theory of matter explains how matter behaves. It states all matter is made up of tiny particles. These particles are always in motion. There are spaces between these particles for energy affects their movement and state. For instance, air pollution spreads because gas particles are in constant motion, making clean air important for our health. However, access to clean air is not the same for everyone. In some low-income areas, pollution levels are much higher due to industrial activities and lack of regulations. In the coming episodes, we'll uncover how pollution and human activities amplify the greenhouse effect, fuel global warming, and reshape the future of our climate, ecosystems, and societies. Matter exists in different states, each with unique properties: solids, liquids, gases, and plasma. Solid state. In solid state, particles are so tightly packed together so that they do not move. This makes them to have a very high density. But if solid are exposed to heat, they make small vibrations about their fixed positions. Solids have a fixed shape and fixed volume. This means they do not flow to take the shape of their container, and they occupy the same amount of space regardless of the container they are placed in. For example, large stones are often crushed into smaller pieces in quarries and factories so that they can fit into trucks, bags, or containers more easily. Since solids cannot naturally change their shape to fit available space, their size must be reduced mechanically. The properties of solids are also important in medicine. Most drugs are manufactured as solids because their molecules are tightly packed in a stable structure, making them long-lasting, easy to store, transport, and accurately dose. However, many medicines are kept away from direct sunlight because light can break some of their chemical bonds, reducing their effectiveness and causing them to spoil more quickly. Almost everything surrounding us in a solid state. liquid state. In liquids, the particles making it up are more loosely or fairly packed than in solids. The particles in liquids are more able to flow around each other, giving the liquid an indefinite shape, making it to fit into any shape of the container as long as it can contain it all. Gases. In this state, the particles are very far from each other and are in motion far more than the particles that make up a solid or liquids. A gas does not have a fixed shape or volume. If it's not in a container, it spreads out without limit. If it is in a container, it fills the entire space inside. Water is essential to life, existing as a solid in form of ice, in liquid state as water itself, and in gaseous form as steam. However, in many developing communities and societies, access to clean drinking water is still a major challenge. Plasma is the fourth state of matter after solid, liquid, and gas. Plasma occurs at extremely high temperatures. Plasma is not a common state of matter here on Earth, but it may be the most common state of matter in the universe. Recently, it was thought of as a subset of gases, but these two states behave very differently. Plasma makes up the sun and stars, and it's the most common state of matter in the universe as a whole. It has a lot of more energy than the other three states of matter because it is charged. Adding or removing heat energy from matter causes a physical change as matter changes from one state to another. A solid absorbs heat and becomes a liquid that is melting. A liquid absorbs heat and becomes a gas that is boiling or evaporation. Then, if a gas or steam loses heat, it returns to a liquid again, condensation. And if a liquid continues to lose heat, it becomes a solid again, that is freezing or solidifying. These changes play a key role in weather patterns, agriculture, and water conservation efforts. But the most common advantage is a biological process that occurs in human beings: sweating. During sweating, there is a release of a salt-based fluid from our bodies. This keeps us cool and comfortable and prevent our bodies from overheating in hot environment conditions. Sweating can also occur in many forms, such as sickness, when the body is fighting diseases. From the solid ground, we stand onto the invisible air we breathe. Matter is the foundation of our physical world. We've explored its forms, its behaviors, and the science that explains it all. Understanding matter isn't just about passing exams. It's about making sense of the world, using knowledge to solve problems, protect our environment, and make smarter choices as citizens of the Earth. So, whether you're curious about why ice melts, how steam rises, or even how smells travel across a room, remember, it's all part of the fascinating story of matter. In our next episode, we'll explore how the particle theory of matter explains diffusion and Brownian motion, and how these invisible actions have visible effects in our lives.